Software projects can often feel like giant black boxes of sheer chaos, right? It's just this constant whirlwind of moving parts, super tight deadlines, and shifting requirements. Well, let's jump right into this explainer and demystify the abstract concepts of project management. By using UML, the Unified Modeling Language, we're going to build a cohesive mental model that takes that chaos and transforms it into absolute clarity.
Start by asking yourself something fundamental. How do you actually keep a massive software project from just collapsing under its own weight? Think about the pure reality of it. You've got hundreds of overlapping roles, conflicting schedules, and this overwhelming nonstop barrage of communication. Without a solid structural solution, it isn't just hard to manage, it's practically destined to fail. And that is exactly why we need to map out the anatomy of what we're building.
So here's our roadmap for this explainer. We'll start with the anatomy of a project, then move into structuring teams and roles, map out tasks and products, dive into scheduling and timelines, and finally, explore the communication nervous system.
All right, kicking things off with Section 1, Anatomy of a Project. If we strip away all those overused corporate buzzwords, what exactly is a project at its core? Well, in our context, it's a comprehensive system made up of 4 distinct, totally irreplaceable elements. You have work products, schedules, tasks, and participants. Without all 4 of those working together, you don't actually have a project, you just have an idea.
Notice how elegantly this UML diagram validates that exact definition. Look at the central entity there, the project, highlighted in yellow. See those little diamond-shaped arrows pointing up to it? In UML, those represent composition. This elegantly proves that a project isn't just, loosely related to work products, schedules, tasks, and participants. It is literally composed of them. They are the molecular structure of the whole thing.
And just like any living organism, a project has a distinct life cycle. This state machine diagram brilliantly shows how a software project behaves over time. We kick off chronologically with the definition state. That's where you're locking down the scope. Once that's set, we transition to start to assign tasks. From there, we enter the steady state. This is the engine room, right, where the system is actually being developed. Finally, once the work is done, we hit termination and deliver the final product. It's a clean, totally predictable flow of life.
Moving right along to Section 2, Structuring Teams and Roles.
When you're structuring a team, you're usually forced to choose between 2 entirely different philosophies: hierarchical versus liaison-based team structures. This is the classic showdown between traditional, rigid, top-down management and a much more modern, dynamic, peer-to-peer system. Let's see what this actually looks like under the hood.
First up is the traditional hierarchy, and honestly, this perfectly illustrates the classic corporate bottleneck. Notice how the user interface, database, and control teams are totally siloed down at the bottom. If the database team needs to coordinate with the UI team, there is literally no direct line. All status reports have to flow vertically up to management, who then processes it and sends decisions back down. It's very orderly, sure, but it is incredibly slow and a total magnet for miscommunication. Now contrast that with the liaison-based communication structure. Look at how beautifully dynamic and interconnected this is. Instead of that massive management bottleneck, we have specific people acting as direct bridges. For example, Alice is a team leader communicating straight to management. John, the API engineer, talks directly to the architecture team. Cross-functional communication happens right there at the ground level. It lets information bypass management entirely when needed, which drastically speeds up the development cycle.
The crucial takeaway here is that to make either structure work, you absolutely need clearly defined roles. In the software industry, the list of job titles is basically endless, right? Scrum Master, Lead Architect, QA Analyst. But if we distill them all down, they essentially rest on 4 foundational pillars: the developer, the liaison, the manager, and the consultant.
Let's look at how this builds visually. Here's a UML taxonomy mapping out that hierarchy of roles. You can see our 4 core pillars branching directly off the main role concept. Now, check out how the highly specialized positions inherit their traits directly from those core pillars. An API engineer or a tester, they're really just specialized types of liaisons. A team leader is a type of manager. Even an end user or a client is formally categorized as a consultant. It takes the absolute chaos of human resources and turns it into a perfectly logical framework.
All right, on to Section 3, Mapping Tasks and Products.
This right here is the core engine of project management logic. Follow the lines with me.
A unit of work, which could be a tiny task or a massive activity, is formally assigned to a specific role. And when that role executes that unit of work, it definitively results in a work product. It's a perfect, closed cause and effect loop. Effort is systematically applied by a specific person to a specific task, which predictably generates a very tangible result.
To really ground these abstract UML boxes in the real world, let's look at what those work products actually are for, say, a database subsystem team. We aren't talking about vague feelings of progress here. We're talking concrete deliverables. The class model for persistent objects, the actual raw source code, highly detailed test plans, even the inspection defects document. Every single task a developer takes on has to output a tangible artifact just like these to prove the project is actually advancing.
Next up is Section 4, Scheduling and Timelines.
What's genuinely fascinating here is that you're looking at the exact same scheduling data represented in two entirely different ways. Over on the left, we've got the classic Gantt chart. It's fantastic for visualizing sheer duration, right? You see exactly how many days a task spans across November and December. But look over at the PERT chart on the right. The calendar timeline is totally stripped away and replaced by arrows. This perfectly highlights your critical dependencies. You can instantly see that you absolutely cannot start the test plan or the implementation until that object design is 100% finished. Two views, one very powerful schedule.
And finally, Section 5, the communication nervous system. Take a second to really appreciate this master model. It synthesizes everything we've talked about into a single cohesive view. At the top, in green, you've got the organization, the teams, roles, tasks, schedules. But look at the bottom half, circled in red. That is communication. This shows how both planned communication events, like a scheduled review, and unplanned communication events, like a sudden request for change, connect right back to the organization. Every single meeting, bug report, or email is formally mapped to a specific role and task.
Digging just a bit deeper into that nervous system, we have to recognize the functional differences in how we actually communicate. This highlights that planned communication, like a client review, is typically supported by a synchronous mechanism. Think of a live meeting where everyone is present in real time. Unplanned communication, on the other hand, like problem reporting, relies heavily on asynchronous mechanisms. This lets team members flag issues and respond whenever they actually have the bandwidth, which prevents a single random bug report from totally derailing everyone's day.
And here is what that abstract asynchronous mechanism looks like in actual practice. This is a real-world example of an issue-based discussion thread. You can see Alice Parker raising an open issue about dispatcher access. Then Dave and Ed jump in, listing out the pros and cons asynchronously. They are actively navigating unplanned technical hurdles, resolving architectural decisions, and creating a permanent record of their reasoning, all without needing to schedule a single synchronous meeting. So, as we wrap up this explainer, I want to leave you with a provocative thought to chew on. How does your own team balance the rigid structures of planned work with the chaotic reality of unplanned communication? We've seen today how UML can elegantly model the anatomy of a project, transforming abstract chaos into tangible structure. I highly challenge you to apply these visual concepts to your own teams. Diagram your roles, explicitly map your tasks to tangible work products, and critically evaluate your communication nervous system. Understanding your anatomy is the very first step to mastering it. Thanks for joining me for this explainer, and keep learning.